Okay, I'm going to be showing you how to solder up, or rather showing you how I solder up a Polar Shield kit. Here's a workbench, the things we need for it: solder paste, sharp tweezers, box of components, parts list, some magnifiers. I have previously done all this by hand by using regular solder rather than reflow, which is this sort of stuff. It doesn't need to be super thin or anything like that. You don't need to have a super thin tip on your soldering iron. What you do need is some sort of magnification and very good lights. This little pair has actually got a little light on the front of it, which is great actually, but it burns through batteries. It doesn't really last very long. I've got this overhead thing which is pretty good actually. It gives you good even light and it's got a magnifier on it. I don't find that very useful because to get close enough to use it I end up steaming it up with my nose anyway. But a quicker way to do the soldering is to use reflow. So we apply a little bit of solder paste to all of the pads, place all the components into the paste, and then give it a quick blast with the hot air gun, and that just works really well. It's easy enough to do 5 or 6 at a time, whereas the other ones it would have taken probably 40 minutes to do it. I can do probably 5 or 6 in an hour, so it's quicker. It seems to be cleaner as well. I think it's a better way of doing stuff. There's still some of the very small things like this. I lack the dexterity to get the right amount of solder paste to squirt out, so sometimes I've got to clean that up with the iron after the fact and suck some of the solder off and redo that. But it's certainly a lot faster than the alternative, which is to melt a little blob of solder onto one half of the pads, then place the component, and then hold it down and stick it on, and then do a separate soldering maneuver to fasten the other side down. That's slow. It's fine for most things, but if you want to do more than one, it gets tedious after a while. I'm not sure how useful this video is actually going to be, because these things you can see are fairly small. That's the size of the resistor which is going to be going onto that. So there's a limit to what you're going to be able to see while I'm actually working on it, but I'm just going to put it up here anyway, and you can see the general process of doing it here. I'll just be doing one here, whereas normally I do a batch of them. Okay, the first step is to apply a solder mask, and this comes in this little syringe. It is slightly sticky, but not as sticky as you probably would want if you were going to be sticking things down with it, so it's not quite as useful as you might hope. However, it is sticky enough. It's just sometimes a little bit not sticky enough to stick to the pads, which is irritating. So just apply a stripe to these on the basis that when you melt it all, when you reflow it all, the solder mask on the board prevents bridges from being made, and miraculously it actually does as well. So for these ones, one long stripe. Again, some of these I tend to sometimes touch up after the fact, because when you actually do the reflow, sometimes the first one to go molten sucks up all the solder from the rest, so you end up with one big full sort of socket and a bunch of empty ones. Let me just move that component to one side. So you can see that already this is a lot faster than, if you can imagine, each one of these components would take a I don't know, 45 seconds a minute to do normally. You can do a bunch of them just like that. So that is going to be that is everything, I think. Is that right? Okay, these ones are missing. Because I'm making up a vitamins kit, I also apply the solder, also add these components. The reason that these components are not on the usual kit, on the ordinary kit, it's not because I'm just being a cheapskate. It's not just that. It is because when the full kits that I supply, I know that they come with good quality Arduino boards, so they don't necessarily need the extra 3.3 volt voltage regulators. They've got good ones built in, and I know that. Whereas the cheap clone ones, which I have bought in the past, don't have those. So, and I don't know what this is going to get plugged into, and I don't necessarily want to say, oh, it has to be this kind of machine, Arduino. Right, so I'll start populating the board. The first one here goes on here. You have to try and put them on the right way around, because it just makes it a little bit easier to figure out what's going on if you ever need to do any troubleshooting. So these are, to show you the box, I've got a bunch of boxes of components, each one labelled with what they are. They are more or less in the order that they get applied in, and that makes everything just a little bit easier. R18 and R19 are both 10k resistors. Where's 18, 19? There we are. Just turn them around. There we go. 18, 19, so that's that one done. 15k resistors. Oops, sorry. Just knock that with my head. 15k goes in here, R2. 1k, R12 and R41. Oops. R12 is here. This is the current limiting resistor for that one. There. And here is the limiting resistor for the main power. 100k. Need two of these. They are these go in R5. And R6. And you can see squish them down into the solder paste. 10 ohms is going to be R13 and R26. It is much easier to do this stuff if you've got magnifiers. If you try and do it by hand without magnifiers, then you're on a hide and do nothing. As soon as you've got anything that magnifies, then your hands become so much steadier than you would think. And it is to do with the magnifier. It's not to do with the size of your tweezers or the size of your soldering iron or the size of your solder or anything like that. It's just to do with the magnifiers. Having magnifiers just makes your hand that much steadier. It's magic. Something interesting to note there with this one. Where did I just put it? These two, 13 and 26. They actually have slightly different markings on them. This is because I've accidentally mixed up two batches of components. This one on the side here has got 100 on it. It's 100 ohms, and this one on the other side of it has got 10 R0. So it's just two ways of referring to the same thing. I try not to mix them if I think on, or if I get a chance. I try not to mix them because you might look at them and then go, "Oh, wait a minute. If these are both the same, then why have they got different labels on them?" And it's just going to lead to confusion at some point. Just for myself, if nothing else. You might think there's a special reason for that, for those being different, and there isn't. It's just the look of the drawer, which ones happen to come out the bag. Okay, it's 4.7K. Next up is a little op-amp package. One of the reasons this is so much faster than doing it manually is because we don't really need to do fluxing. Yeah, I don't need to add flux separately, whereas if you're doing it manually, everything needs to be fluxed beforehand. One end soldered on, then flux added, and then the second end soldered. So it's not really that much faster than through-hole stuff. You don't have to clip the leads and you don't have to turn the board over, and that's the main kind of benefit of it, but it's not great otherwise. Right, green LEDs. These little LEDs, tiny little package. Oops, that's right, tiny little package. They have a mark. I don't think it's going to focus on that. They have a mark on the back anyway, and there's a mark on the front, but it is truly minute. There's one side which specifies the cathode, and I'm going to put which one does, it's this one, isn't it? There's a little tiny little spot which says which side the cathode is, so that needs to go that way. Green LEDs. Now red LEDs. Two of. This goes the opposite way around. One in the power there. That was this one I just put on. And oh bugger. Yellow LEDs. Now I kind of wish I'd made all these LEDs the same colour. It would make it easy to apply, but when I first got these I was overexcited about having 3 different colours and thought I'll use 3 different colours, and forgetting that if I'm going to be able to offer any help to anybody in the future, then all of them have to have the same 3 different colours on them, and the places have to match and things. So I wish I just used one colour for all of them. But maybe sometimes better you can say, oh, is the red LED in that? Is the red LED on, or is the green LED on? And that's maybe a troubleshooting thing. I probably actually did that for a reason. There's actually some brains behind that, but sometimes I wish I hadn't, and I just done it rubbish instead. So these components are resistor networks. So these are just 4 resistors in a row. That's literally all they are. The first versions of this board, the red ones, these are all discrete. So there's tons of these little things. Of these, actually only 3. No, they're all used actually. There's one of these ones. There's only 3 of them used anyway. But it's so much easier just to use a package like that than it is to solder on 4 tiny little ones. You've got to be a little bit more confident with your board design. But that's, I mean, this is literally only the 2nd version, so it's not like it's rocket science. Just stick these in. These are quite satisfying because, you know, there's lots of work gone in there that you're avoiding. It's amazing to me that this actually works at all, and that you don't get bridges underneath, but apparently you don't. I haven't had any so far, and I'm not going to start complaining about that now. So I've got a couple of capacitors to go on. These little ceramic caps. One for the motor supply. One for the 3.3 volt supply voltage reg, and now a couple of tantalum caps. Now these are polarized, so I know these need to go that way. There should be a marking really on the silk screen here on the board to tell you to do that, but there isn't one. And the regulator, which is here. This is actually was the main reason that I got the hot air station, is to do this bit, because this is a pain to put on using just an iron, because the surface area is so big, it just soaks up heat and it just won't melt. And this is a little bit the same, this part here. These take a lot of heat to melt the solder on them. And I'm always a bit afraid I'm going to end up melting the component instead. And I suppose with the heat gun, it's I don't know. It seems like it would be more risk of that. Oh, it was close. Some of these things are of a size which is it's actually easier to use your hands sometimes, to use your fingers rather than tweezers, because this is just big enough to grip, but then I can't widen it any further to actually let it go. So end up moving it off the pads just as you try and take this two tweezers away. Right, so that's everything put on there. I'm going to just take my hot air gun. I said hot air gun there. And I'm just going to start, wait for it to get up to temperature. It's up to 400 degrees. And I'm just going to start playing it over the components. I'm going to use this one at the side here. I don't know how useful it's going to be to actually see it, whether you'll be able to see it or not, but let me see and try and get in there. You can see it soldering, see it melting. And as it melts, you can see them sort of pull into place there. I'll do these ones next. Some of them take longer than others, and it's mainly to do with the amount of metal that's in the traces around them. Oh, that one has sort of tombstoned almost, and that is where there's a bit of it which just this isn't a good example. I'm not normally this clumsy, right? But that's just sort of where the tension on one side of it, they're not being melted equally, and one is pulled out. So there we go. That's better. That's a better one. So you can see there's a little pool of flux there as well that it sort of beds in. I'll do these ones here. There we go. They sort of pull into place, which is actually nice to watch. And then you see the surface tension go. And the whole thing actually gets up pretty hot. It's difficult to say. It's difficult to see it rather just from watching it. It doesn't really. Of course, it doesn't really sound stupid, but it doesn't really look hot. But they do actually stay molten for quite a while. Oops. I'm trying to give you some light there and actually move the camera away instead. I'm just going to swap hands. So again, those ones are a bit difficult to do previously by hand, just because they suck up so much heat, because they're near to the power traces. So there's a lot of copper on the actual bed there. I think that did it. That flowed. Yeah, it did. And that's quite pleasing to see that. See the whole thing just shift into place there. I'll quickly do these. Do these. And give the whole thing a bit of a preheat, just so it's up to a fairly steady temperature before zooming in and getting them melted. So you can see there that as soon as the paste melts, it kind of beads up the surface tension, pulls the parts into place. Yeah, you see there's a couple of little beads of solder still floating around there, which I'll take off with an iron in a minute. In fact, I'll put that on now. So there we go. That was more or less that. So this will still be hot, so I'm going to put my hand on it and burn myself. Most of those joints don't even need worrying about. There's one here which maybe I might add a little bit of a little touch of solder to. It probably is conducting okay, but I don't know if it's actually conducting because it's got any solder in it, or if it's just because it's held next to it. Right, there's a couple of little beads there. Some of these you can just push off, but you would tend to use a just a hot iron just to collect them on the tip. There's that. That looks okay. This socket here looks a little bit sparse, but otherwise that looks fine. Now this is the part which I normally have to clean up. Looking at that, there is a bridge between these two pins and these two pins, and that side might be okay. There is a bridge between those two pins there, but in fact that doesn't matter because there is a bridge in the circuit anyway between those two pins. They're just AS pins. So what I'm going to do is get a bit of solder braid. Where have I put my solder braid? There it is. Clean soldering iron tip. Clean solder braid, ideally. Like that. At least to show a good example. So just push that in there. Bear in mind that these gets really hot. I made the mistake first off of gripping it very tightly and then burned myself promptly on the solder braid because, you know, I forgot that. That's one of the things that copper does. And to repair this, I'm just going to use this very, very fine solder. I probably don't actually need to repair this, but I like to just put a little extra blob on. Err on the side of caution in this case. So that's that done. Use the bigger stuff to clean up the rest of them. There's that gap there. I reckoned maybe was a little bit sparse. Again, it probably actually isn't this. I probably could get away without doing that, but it does no harm, and it makes for a more uniform appearance. If nothing else, it kind of looks better, and that makes it that little bit clearer. I'm not going to bother fixing that one. That looks fine. Everything else looks fine, I think. I'd like to have a little bit more solder on there probably, but it's enough. I just don't like to see the outline of the part too clearly on it. These ones where the solder actually underneath it, it's difficult to say exactly how much is on it because it's all been sucked in, so it probably is fine, but it's just because I'm comparing it to what it would look like, what it would have looked like if I'd done it by hand, and that's not necessarily a fair comparison because, you know, they could look awful done by hand and be a brilliant joint, and alternatively could look perfect done by hand and be a terrible joint. So that's that. Is that hot? No, it's not hot. So I will use a bit of cleaner on that. Just squirt it down. Give it a scrub. Just to clean the flux off it. This is no clean flux that I use on here anyway, so it's not like it's not going to be corrosive or anything. It just looks grotty and kind of goes furry as well. I don't know if that's something, if I'm really my ignorance, but I know why does it go furry. But I came across one, I was like, oh my god, it's gone mouldy or something, but it wasn't. Well, maybe it was mouldy, I don't know. So there we go. So that is a Polagraph, Polar Shield rather, soldered up, and well, soldered up with all the surface mount stuff anyway, and ready to have the through hole stuff mounted onto it. Oops. So these parts here, there's a bunch of jumpers on the top of here which I just put on to hold the pins in place while it's being soldered. Otherwise the plastic that the pins are stuck in gets a little bit soft when it gets hot, and they sometimes go a bit out of alignment. So I just put the little caps on them in the meantime, and it just means they get held straighter and the heat gets distributed through to the other pin as well, which helps it preheat further. I'm going to need to do that in a minute anyway. And I made sure beforehand that these ones were in straight, because there's not much else to hold them in place, and that one it's not very much in straight there actually, but it doesn't really matter, it's not going to plug into anything, so it's fine. I'm not going to worry about that.